again to my followers, to my viewers, and of course to my subscribers and learners. So I know it has been a very long time since I updated my channel, and I'm really sorry for that kasi nagkaroon ng local lockdown dito sa amin. At the same time, habang merong lockdown, I was been very preoccupied with my hobby, which is gardening. So nagtatanim ako ng mga gulay. Anyways, upon checking my channel, nagulat ako kasi maraming mas naging interested sa akin because I really missed you so much. So our video for today is all about lessons on physical science. The content is all about the first module of the fourth quarter in the second semester. And I bet this will be very interesting to all because we're going to deal with the cosmos. We're going to have a glimpse of the history about how we came to realize and to know that the Earth is not the center of the universe. So let's not make the bacon cold. You have probably gazed at the sky on a clear night, right? And maybe you wondered if there are aliens or any parallel universe out there. So as the advent of space explorations, the notion of living on Mars has already been accepted or presented by some people just in case our Mother Earth ceased to be a habitable planet in the future. Yes, nowadays, sa mga videos, probably nagkakaroon tayo ng considerations na what if we live on Mars if the Earth ceased to exist. Okay. Or maybe you are planning to go on a vacation and your destination is on the outer space. Isn't it cool? Of course, I bet, because it will be a very first time experience, probably to all of us, commoners. Yet, ancient people did not think about these aliens or any parallel universe. But one thing is for sure, that they are also curious about their surroundings and they tried to seek answers and explanations. So in this lesson, we will able to explain how the Greeks knew that the Earth is spherical. Let me show you this illustration. If we're going to align two balls horizontally, we're going to point a flashlight on each. We'll able to observe that it casts a shadow on the ball behind it, right? And what do you think is the shape of the shadow? Sphere, isn't it? Just like you and me, before the Greeks and the rest of the ancient people were able to formulate theories about the sky and the earth, they made a careful and repetitive observation about the phenomena around them. The Mesopotamian, as accounted in their methodology around 6th century BC, they believed that Earth is a flat disk floating in the ocean and bounded by a spherical sky. This idea was prevailed for hundreds of years until a new view was presented. As the quest for knowledge continues and civilization prospers, several models of the universe were presented. And it is categorized as geocentric or earth-centered, as proposed by Ptolemy, and heliocentric or sun-centered, that was proposed by Copernicus. In a heliocentric model just like this, the Earth was at the center of the universe and the rest of the heavenly bodies and planets revolve around it. While in geocentric model, just like this, the sun was at the center and all the heavenly bodies, including the earth, moves around it. In all the geocentric models of the universe, the earth and other heavenly bodies were assumed to be spheres. And they were convinced that the shape of the earth is not a flat disk, but spherical. This idea was already been entertained by Pythagoras and Plato, one of the greatest philosophers of that time. But they did not have concrete evidence, so their claim was not supported. Until Aristotle, around 320 BC, a student of Plato, presented his arguments that established their claim during their time. Aristotle argued that the sphere is perfectly solid and the heavens are a region of perfection. Secondly, the Earth's component pieces falling naturally towards the center would press into a round form. Third, in an eclipse of the moon, the Earth's shadow is always circular. Thus, if Earth is a flat disk, it would cast an oval shadow. And lastly, even in short travels northwards, the pole star is higher in the sky. Another phenomenon considered by Greek in their claim that the earth is spherical was navigation. They observed that when ships sails away, it seems that it gradually disappears behind the horizon. If it is not a sphere, then why measure its circumference, right? One of the astronomical events that fascinated the early civilization was the eclipse. Just like this. And the recorded information about the eclipse was used by Eratosthenes around 235 BC to approximate the circumference of the earth. This was another proof presented about the spherical shape of the earth. As you know, an eclipse is a shadow formation, right? This happens when the path of the light rays is blocked by an object. Eratosthenes, while working as a librarian in the University of Alexandria in Egypt, he came across information during the summer solstice, especially at noontime. Sunlight shines directly down a deep well in Sion, a city of Alexandria, and reflected up again, and no shadow is being cast by any objects in a noontime. But in Alexandria, at the same date and time, a vertical pillar and other structures, maybe it was a building or a sculpture, cast the shadow. And so, Eratosthenes, whatever, measured the shadow cast by a vertical pillar in Alexandria, just like this figure. And he found out that it is 1/8 of the height of the pillar. This is roughly equivalent to 7.2 degree angle between the sun rays and the vertical pillar, while in Sion it's 0 degree. Based on his calculation, 7.2 degree is equivalent to 1.50th of a circle. Thus, it follows the distance between Alexandria and Sion must be 1/50 the circumference of the earth, or the earth's circumference is 50 times the distance between the two cities. Since these two cities, the Alexandria and the Sion, are frequently traveled, the distance was measured to be 5,000 stadia, or it is equal to 8,000 kilometers. So, the Earth's circumference is 50 times 5,000 is equal to 250,000 stadia. So, according to this illustration, when the rays shine directly above at Sion, the deep well, it is not directly overhead at Alexandria, which around 800 kilometers away north. The pillar in Alexandria cast a shadow, while the water in the Sion, or the water in the deep well at Sion, directly reflected the sunlight. So, are you now convinced that it is indeed the earth is spherical? Siyempre naman, ginamitan ni Eratosthenes ng mathematics. Hindi ba kayo maniniwala? So, ngayon alam na natin, kasi sa mga movies pa lang makikita na talaga natin, there are people who travels on the outer space and they see it directly or personally the shape of our planet, right? So, alam na natin talaga ngayon that Earth is spherical. We are done with the lesson 1 and let's move on to the next lesson, which is all about the astronomical phenomena known to astronomers before the advent of the telescope. So, in lesson 1, we have learned how the Greeks knew that the Earth is spherical in shape. The presented evidence like the arc-shaped cast shadow or the arc-shaped shadow cast by the Earth and the Moon during the mathematical evidence given by Eratosthenes when he measured the circumference of the Earth. So in this lesson, we will learn more about the examples of the astronomical phenomena discovered by the astronomers even before the invention of the telescope. So in this modern time, we come to know the things around us, right? Because we have appropriate instruments and gadgets to study or analyze such event or phenomenon. Just what I have mentioned earlier. Dahil meron na tayong mga gadgets, we can travel in the outer space, and able to, identify and we can able to learn more and accurately nowadays. Taking for example is the telescope. This is one of the instruments invented by mankind, which is very useful and helpful in studying cosmos, right? So, but despite the absence of a telescope in ancient times, still they were able to discover some astronomical phenomena, just like the periodic motion of the sun across the sky. They noticed that the sun rises from the east and sets in the west. So this is some of the astronomical phenomena or events that was studied by the ancient people. Number one is the phases of the moon, as you can see in this figure. The appearance and path of the moon were observed by ancient people to change within 29.5 days. They observed that the moon changes appearance from a thin semicircular disk to a full circular disk. The periodic change of the moon's phases were the basis of the ancient calendar. Another astronomical phenomena is the lunar eclipse, as you can see in this figure. This is one of the things that caught the attention of the ancient people, that there was a time in a month when the moon or part of it are seen to be covered by a shadow for a brief moment. A phenomenon such as this is called the lunar eclipse. A lunar eclipse occurs when the earth is in between of the moon and the sun. The earth casts a shadow on the moon. Thirdly is the solar eclipse. A solar eclipse happens when the moon is in between of the sun and of the earth, and the moon is partially or completely covered or blacked out of the sun. This caused temporary darkness during daytime. So the ancient people feared of the solar eclipse because since they associate it with the wrath of God. So siguro iniisip nila na galit sa kanila yung Panginoon pag nag-totally black out yung ating araw. Next, astronomical phenomena is the motion of the stars. The astronomers noticed that the constellation positions in the night sky vary depending on the time of the year. It was also observed that the star seems to be attached on a celestial sphere that rotates around an axis in one day. So as you can see in this figure, maybe they wondered that some stars moved. Okay. Astronomical phenomena that was observed by the ancient people is the visibility of planets. They noticed a few stars in heaven that are relatively brighter than the rest of the stars. The distant stars seems to be fixed in their position, but these stars change positions periodically. Thus, the Greeks called it the wanderers or the planets. These wandering stars are the Mercury, Venus, Jupiter, Mars, Saturn, which later discovered as planet, not stars. Now that you have learned about the different astronomical events that was discovered by ancient people even before the advent of the telescope, from the information that they gathered, it has resulted in the innovation and invention. One of this is the calendar. So we must be very thankful of those people that discovered these astronomical events because we have now the so-called calendar. And through this, we can able to identify the time of the year and the day, of course. Now we are done with the lesson 2 and let's move on to the next lesson. So in lesson 2, we have learned that the discovery of astronomical wonders even without the aid of the instruments like the telescope. Aside from that, they also made us realize that our surroundings, not only heavens, have a great influence on one's way of living. So in this lesson, we will be able to explain the Brahe's innovation and extensive collection of data in observational astronomy paved the way for Kepler's discovery of the law of the planetary motion. The knowledge about the universe starting from the ancient times up to the present has proven to be a dynamic one, right? The discoveries weakened the foundation of a theory that thought to be correct and widely accepted, but later on it was, being corrected. And in the process of revolutionizing the data, one must be able to back with claim and proof. The best proof one could present is the data which is verified and tested several times, just like the works of Tycho Brahe. We have learned that the geocentric model of the universe have prevailed for thousands of years, right? Yun yung mga pininiwalaan ng mga sinaunang tao. Only after or in the later part of the 16th century that this idea was questioned by Nicholas Copernicus, wherein he proposed that it is the sun, not the earth, was the center of the universe. The conflicting ideas and pieces of evidence in both models have pushed Brahe to come up with his own model, backed with his accurate measurement of the distance and positions of the planets and the stars. He proposed the geo-heliocentric model, or the so-called Tychonic model, a hybrid of the geocentric model that was proposed by Ptolemy and the heliocentric model that was proposed by Copernicus. In his model, the geo-heliocentric model, the sun orbited the Earth and the other planets orbited the sun. It was also during this time that Brahe met the young German mathematician named Johannes Kepler. So let us know about their story. So Brahe hired Kepler as a sort of research assistant, primarily to prove that Brahe's model, the geo-heliocentric model, was the right model. Kepler's task is to fit the data that was collected by Brahe into the model he proposed by doing the mathematical calculation. Unfortunately, this is very so sad. Brahe died before his model was proven. Syempre, pag namatay ang presidente, talagang magti-take over ay ang vice-presidente. In the case of Brahe and Kepler, Kepler inherited a vast set of data that will prove crucial for developing the three laws of planetary motion later. Kepler spent many more years. Hindi din naman siya nagmanala. Hindi naman siya, wala nang ginawa, di ba? He spent many more years trying out many possible models to fit the available data that he inherited. But Kepler failed to reconcile the data. Hindi pa rin siya nagtagumpay with the model Brahe proposed, especially on the notion that the Earth is stationary. Yung hindi daw gumagalaw yung Earth. It's not moving or revolving. It took another brilliant mind and his invention of the telescope, and it is Galileo Galilei, to prove that Copernicus' theory is right, proposing that the sun was really the center of the universe. But despite everything still, something good came out of his persistence. Dahil napakatyaga ni Kepler, hindi naman nasayang ang kanyang pinaghirapan. After about 20 years, diba? Mula kinder hanggang college ka, parang ganun, 20 years. And so working with the data he got from Brahe, the three laws of planetary motion were published in two different ways. The first law is the law of elliptical orbit, or the law of eclipse, just like this one, where the planets move in elliptical orbits with the sun and a focus, and the other focus is empty. The second law is the law of equal areas. As the planet orbit around the sun, the planets cover equal areas in equal time. For this to happen, as shown in this figure, when below the point A and B, when the planets are the nearest to the sun, and it moves and the lowest at point in C and D, when the planets are farthest from the sun. Remember, when the planet is nearest to the sun, it is called perihelion. And when the planets are farthest from the sun, it is called aphelion. The last law of Kepler is the law of periods. Okay, the ratio of the squares of the periods, or the time needed for one revolution about the sun, of any of the two planets revolving around the sun, is equal to the ratio of the cubes of their mean distance from the sun. That is T sub 1 and T sub 2 represents the periods for any two planets, and R sub 1 and R sub 2 represent the mean distance from the sun. Then, this is the mathematical representation of this law, meaning that R raised to 2 and or T raised to 2 should be the same or constant for each planet. To determine the value of proportionally constant, or K, the value of Earth's known orbit could be used as T, or for example, the T or the Earth is equal to 365.24 days. And the R, or R of the Earth, or the distance from the Sun, is 149 million kilometers. Or, we can say it is 149,600,000 kilometer, or 149.6 times 10 raised to 6 kilometer. Okay. So, if we're going to solve the R3 and the T2, the R3 and the T2 is equal to K, or the proportionally constant, right? So 149.6 times 10 raised to 6 kilometer cube over 365.24 days is equal to 2.51 times 10 raised to 19 kilometer cube over days. Thus, the ratio of the cube, or the mean of the distance of the Earth from the Sun, and the square of its revolution is 2.51 times 10 raised to 19 kilometer over days. So that's it. And I hope you learned something from my discussion about how we came to know that the Earth is not the center of the universe. And if you have any comments, queries, suggestions, clarifications, please feel free to drop your comments or ask me directly in my Facebook and my email account. And if you are not still a subscriber, please just click the button and the notification bell for you to be notified for more videos. Again, this is Teacher Dana saying, read more, share more, gain more. Thank you very much for watching.